Hello, my lovely friends. This is Amirush, and I welcome you to revision series for grade 10. And today we'll be talking about electricity grade 10 physics, resistors in series and parallel. We'll be revising the concepts as well as we'll be solving a few important questions. So let's get started. Now, two topics that we have over here are resistors in series and parallel. So basically, these are the two combinations in which we can connect the resistors, by which we can connect two resistors or more than that. Now first talking about the resistors in series, resistance in series. So what happens guys, in series we connect two resistors end to end. Okay, like this is one of the resistors, so we'll connect it with the end of another resistor, or you can say resistors are connected one after the other. I hope you know what are resistors. Resistors are the devices which produce the resistance opposing the current, right? So over here, if this is X resistor, this is Y resistor. So I have connected these two in series because end to end. So this is the end of one, there is one resistor, and this is the end, one after the other. I'm connecting them. So you can make it, then the battery and key. And at the end, you need to show how the current is flowing. So in this way, you can make the circuit diagram pretty easily. And equivalent resistance is the sum of the individual resistances. So can you please give me a minute? I want to take a new slide for you. Okay, perfect. Now guys, understand what is equivalent resistance. Equivalent resistance is the total resistance of that particular circuit. If this is my circuit, then my total resistance is going to be my equivalent resistance. Is that clear? Total resistance. So that is the sum of all resistors. Suppose if I have these resistors, I have three resistors with me, R1, R2 and R3. So if I want to find the total resistance, I'll simply add all the three resistances, R1 plus R2 plus R3, and I am done. So this R1 plus R2 plus R3 is gonna give me my equivalent or the total resistance. Just ignore the sound. Okay, this is the equivalent or total resistance. Now, two important facts to remember, that is, in series combination, in this kind of a combination, your current remains the same. It means current, if there is 0.4 amperes current, it is point. Okay, so it will be the same for R1 also, R2 also, R3 also. In all the resistors, the flow of current will be the same, the magnitude of the current, that is 0.4 amperes. Whereas the voltage gets distributed, the potential difference, if it is 5 volt, it will be distributed among these three resistors. Let's say over here 1 volt, here 2 volt, and here the remaining 2 volts. Clear? Now for two resistances, as I said, the formula becomes R equivalent R1 plus R2, the sum of all the resistances. Whereas for three resistances over here, we have R1 plus R2 plus R3, again the sum of all the resistances. And for n resistors, we have R1 plus R2 plus R3 till Rn, till whatever number given. So simply it is the sum of all the resistances, and that is why one important fact that I want to tell you over here is that the sum of all the resistances, that is the R equivalent, will always be greater than the other individual resistances. Understand? Suppose if I have two resistors, 1 plus 1 ohm and 2 ohm resistors, what will be the equivalent resistance? 3 ohms or not? So this 3 ohm should be greater than all the individual resistances, and that is the fact. 3 ohm is greater than 1 also and greater than 2 also. A question for you for checking your progress. I am hiding the options because it's subjective, guys. It's completely subjective, so you need to be in the habit of subjective questions only. Okay, just a second. Let me use the earphones because there was some sound coming from there. Just a second. Okay, now it's better. There are three resistors joined in series in a system having resistance equal to 10 ohm, 20 ohm, and 30 ohm. Just a second. Is it audible? Yes, it is. Okay. If the potential difference of the circuit is 240 volt, find the total resistance and current through the circuit. So how are you going to do it? Come on. Three resistors are joined in series. So let me make the diagram, then I'll be explaining. Just a second. Okay. Okay. Now I'm removing the earphone since the sound has gone. There are three resistors, 10 ohms, 20 ohms, 30 ohms. Okay. And it is connected with the battery of potential difference 240 volts. Now they are asking find the total resistance in the circuit and the current. So how are you going to do it? I will have to take a blank slide guys. Sorry for that, for the disturbance. Hmm. Okay, so if I'm talking about the total resistance, okay, R equivalent will be the sum of all the resistances. So it should be equals to 10 plus 20 plus 30. That is going to give you 3 plus 2, 5 plus 1, 6. 60 ohms is the equivalent resistance. Talking about the current is V by R. Because I know V is equals to IR. Ohms law से मुझे ये वाली इक्वेशन पता है. तो करंट होता है potential difference upon resistance V by R. What is V people? That is 240. मिक्स हो गया, एक सेकेंड रुको. 240 होता है कि नहीं, एंड रेजिस्टेंस कितना है, टोटल रेजिस्टेंस चाहिए, सो दैट इज 60 ohms. Cancel it out and please SI unit sahi likhna. That is going to give you, if I'm not wrong, 4 amperes. देखो 60 ohms and 4 amperes. That is option number A. 60 ohms and 4 amperes. We have का answer. Talking about resistance in parallel. तो क्या होता है resistance in parallel में? That end of the resistors are connected together. That is, if I have this circuit, so this is one of the resistors. So my second resistor will be connected in this way. Okay, the end is going to be connected. See, these are the ends. They are together. You can see. This is the parallel combination, and reciprocal equivalent resistance is the sum of individual resistances. What do I mean by that? I mean by that, if you want to find out the equivalent resistance, that is going to be 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So the reciprocal of equivalent resistance is going to be reciprocal of all the resistors. And if you want to find the final answer, then you will have to reciprocate the answer after adding. After taking out the LCM, you will again reciprocate it to find the R equivalent. And over here, voltage remains the same. It means voltage, if it's 6 volt, it will be for all the three resistors, for R1 also, R2 also, R3 also. Current gets distributed over here. Current gets distributed among various resistors. Suppose R, if the total current is 2 amperes and there are, let's say, 3 resistors, so maybe 2 resistors would get 0.05 amperes and one resistor might get 1 ampere. So in this way current is going to be distributed. So for 3 resistors over here, we can see the ends are connected. देखिए, दिख रहा है? Great. This is the formula that you have to remember. 1 upon R equivalent, 1 upon R1 plus R2 plus R3 for n resistors and so on. Done. And remember over here, the equivalent resistance which you are going to get will be lesser than the individual resistances. चलिए क्वेश्चन सॉल्व करते हैं. ऑप्शंस नहीं मिलेंगे, सब्जेक्टिव है पेपर बेटा. अच्छा, if two resistors 3 ohms and 4 ohms are connected in parallel, what is the resistance? Very easy. This you have to solve by your own. I'm not going to solve. I'm giving you 2 minutes. Quickly solve it. Done. Copy निकालिए, solve कीजिए. Let me know the answer. And do let me know if you're comfortable with English or English. Should I teach you in English or English? Because till now I've been teaching in English. In the past 1 year I've been teaching you in English and you're happy with it. So should I continue या फिर हिंदी में पढ़ाऊँ? Let me know. Okay. So right now let's uh, go with English only because we are not sure about the consent of majority. Okay, two resistors are there, they're connected in parallel. Let's say this is one of the resistor. Let's say this is the second resistor. Done. 3 ohms, 4 ohms. What is the equivalent resistance? So you can find it. See, 1 upon R will be 1 upon R1 plus R2, 1 upon 3 plus 1 upon 4. We have reciprocated them. We're getting the answer is 1.71 ohms. Done. Okay, so we've revised this. In the next session, we will be revising heating effects of electric current as well as the um, power. Okay, so I hope you enjoyed the session. Do not forget to like, share, and subscribe.